Hi class, this is Professor Smith. I've opened up Student View on ALEKS and we'll begin Sample Test 2 on Chapters 5 and 7. For the first problem, we have the manufacturer of a fertilizer guarantees with the aid of the fertilizer 75% of the planted seeds will germinate. Suppose the manufacturer is correct. If 7 seeds planted with the fertilizer are randomly selected, what is the probability that more than 5 will germinate? In this example, they tell us that we have a 75% success rate for seeds germinating. Not germinating would be 25%. So we have two choices. We're assuming that on each seed that's planted, that the chance that that particular seed will sprout is 75%. And so I'm going to open up a spinner game to give an example of exactly what would that mean. In this spinner, I have two colors, pink and blue. We notice that we have 3/4 of the pie is blue, which would be 75%, and 25% would be pink. So we're letting blue be the success of germinating. So what that means is that if we have one seed, we can think of that as one spin. So if we spin it once, we have a count here that says, oh, we got one blue. And we would expect more often than not you would get a blue since 3/4 of the spinner is blue, or every time we plant that seed that there's a 75% of success. And we're going to plant 7 seeds. So if I spin again, that one's also blue. So we've got 2. If I spin again, that's another blue. Spin again, 4 blues. And here we have one that's not blue. Spin again, and we have 5 blues. And spin one more time for our 7 seeds, and we have 6. And the question is asking, what's the probability that you're going to get more than 5? In this particular case, we got 6. So we want to know, what's the probability that more than 5 will germinate, or will be, in this case with the spinner, be blue? So there's a way we can find this. We've just done an experiment here, and we've got in our experiment that we had 85.71% and 14.29. So let's go out and figure out how we would do this using our binomial probability distribution. I'm going to write down that the probability of success, which is the seed germinating, is 75%. And we have 7 seeds that are planted. We want to know more than 5. So I will open up math type so that we can see how we would capture this using pen and paper. I've opened up math type. I have 75% will germinate out of the 7 more than 5. So we really want to find the probability that more than 5 will germinate. We know that the probability of 1 germinating out of 1 seed is 75%, and I'll call that success. And 75%, we can also rewrite that as 0.75. We also know that we have 7 seeds, so that'll represent our n equal to 7. And now we need to translate what is more than 5 out of 7. Well, our random variable is that when we spin that wheel, we could have 0 germinate out of the 7 seeds. We could have 1 germinate. We could have 2 germinate. We could have 3 all the way up. Did I say 2? So 2, 3, 4, 5, 6, 7. So we can have from 0 to 7 of them germinate. And we want to know the probability that more than 5. So if we say more than 5, that would be the 6 and 7. So that would be more than 5. So another way we can write the probability of more than 5 out of 7 will germinate is the probability that x will equal 6 or 7. On the ALEKS calculator, we have a button that will allow us to compute probabilities if we go from 0 to some fixed number. But this has 6 to some fixed number. So what we're going to do is we're going to do the complement. The complement to the 6 and 7 would be 0, 1 through 5, and that would be our random variable starting at 0. Well, in order to use the complement, we need to use the complement rule for probability. So it's going to be 1 minus the probability that x is equal to 0 all the way up to 5. And now that we have our probability starting with 0, we can use the cumulative probability distribution button on the ALEKS calculator. And that's given by the following. It's 1 minus the probability of B for binomial. And then for our first blank, it's going to be whatever n is. So I'll try to create a box for that. And then the next box is going to be the probability of success. And that's 0.75 less than or equal to a certain value. I said, well, how do I know what that value is? Well, it turns out when you have the probability starting at x equal to 0, whatever that last value is, that's going to be the value that you're going to substitute into the ALEKS calculator. All right, so let's go out to the ALEKS calculator and substitute in those values. By the way, if it started at x equal to 0, let's say that it said less than 6 or less than or equal to 5, then I don't need the 1 minus. So if it starts at 0, you don't need the 1 minus for the binomial probability distribution advance. And then I'll have 1 minus the probability of B. All right, and so n will be 7. The next box is 0.75 and then 5. And we again only have that 1 minus because it didn't start at x equal to 0. And so we have a 45%, pardon me, 0.44 chance percent. And they want us to round our intermediate computations, which we didn't do any intermediate. We did it all in one fell swoop with the ALEKS calculator. But let's say that you just did this part first, the P of B. They would want you to do that to 4 decimal places, which would be 0.5551. And then when you subtract it from 1, you'll get 0.4449, which is what we got when we didn't do the intermediate computation. So I always do it in one fell swoop. And they say to round your final answer to 2 decimal places, so we get 0.44. So some key buzzwords that I think will be helpful for us when you're doing these binomial advances to know what do the phrases mean. So again, let's pull up math type and just type in a few. So at least, 5, that really means that x is greater than or equal to 5. And if it's greater than or equal to 5, that really means that the random variable is going to be 5, 6, or 7. Let's say that we had at most 5. Then that means that the random variable is going to be less than or equal to 5. It's saying that the most you can be is 5. And that means you're going to go from 1 to, excuse me, 0, comma 1 to all the way up to 5. So at most is less than or equal to, at least is greater than or equal to. What if you said no more than 5? That means that the random variable can't be bigger than 5. So that means it could be less than 5, but no more than 5. So that means x would equal 0, 1, 2, 3, and 4. Can't pick 5 because 5 isn't bigger than 5. So no more than 5 would be x equal to 0, 1, 2, 3. What if we had no less than 5? So if we had no less than 5, what do you think that would be? That means you could have 5, but not less than that. So it's strictly greater than 5. I should really capture that there for this previous one. So no less than 5, I mean it could be 5 or more. So it's the same as greater than or equal to 5. Could be 5, but greater than counts as well. So those are some of the buzzwords. I think students are okay when we say more than 5. That means strictly greater than 5. And if x is greater than 5, again, it would be that 6 and 7. So x equal to 6 or 7. And then less than 5 would be the complement. That's not true. Less than 5 means x less than 5, and that's not the complement. Less than 5 would be 0, 1, 2, 3, 4. Doesn't include the 5. So that's strictly less than 5. So I hope those buzzwords or key phrases are helpful for you for the first problem, question 1 on the sample test, which is binomial advanced. I'll do another movie on the others as I go. I was hoping to get through them all before tomorrow, but I know that I'm not going to be able to do that. So I'll try to pick the ones that are more difficult, and I'll do the best that I can, but it's taking about a half an hour to make just one movie. So at 16 and a half hours, it would take me 8 hours to produce a movie on every one. So we'll see what we can do.